Hello everyone, welcome back to my YouTube channel Geography with Sumona. I am Sumona. In today's video, we are going to learn about isoline used in climatology. Isolines are one of the most important concepts in climatology because they help us represent different weather and climate elements on maps in a simple and clear ways. Before learning different types of isolines, let's first understand what an isoline is. The word isoline is made up of two parts. Iso means equal and line means a line connecting different points. So, an isoline is a line drawn on a map that joins places having the same value of a particular climatic element, such as temperature, air pressure, rainfall, or humidity. Look at the figure on the right side. Different places have different values, but the blue lines connects only the points with the value 20. This is an example of an isoline. In simple words, isoline help us convert scattered weather data into a clear and easy to understand map. This makes it easier to identify and analyze the spatial distribution of climatic elements. Now that we know what an isoline is, let's learn about the different types of isoline used in climatology. The first type of isoline is isotherm. An isotherm is a line that connects places having the same temperature at a given time or over a specific period. For example, if several places having a temperature of 30 degrees centigrade, they are connected by a single isotherm. Similarly, places with 25 degrees centigrade are connected by another isotherm, as shown in the figure. Isotherms are very useful because they help us understand the distribution of temperature across different regions. They also help us identify hot and cold areas and monitor heat waves and cold waves. In simple words, an isotherm is a line joining places with equal temperature on a map. Now let's move on to the next slide. The second type of isoline is isobar. An isobar is a line that connects places having the same atmospheric pressure. For example, if different places have an atmospheric pressure of 1010 millibars, they are connected by a single isobar. Look at the figure. The letter H represents a high pressure area while L represents a low pressure area. Isobar help us identify this pressure system. They are also very useful in weather forecasting because they help meteorologists understand wind direction, wind speed, and the movement of weather system. In simple words, an isobar is a line joining places with equal atmospheric pressure on a map. Now let's move on to the next slide. The third type of isoline is Isohyet. An isohyet is a line that connects places receiving the same amount of rainfall during a specific period, usually on year. For example, all places receiving 100 centimeter of annual rainfall are connected by one isohyet, while places receiving 50 centimeter of rainfall are connected by another isohyet as shown in the figure. Isohyet help us understand the distribution of rainfall in different regions. They also help us identify wet and dry areas and are very useful for agriculture, water resource management, and climate studies. In simple words, an isohyet is a line joining places with equal rainfall on a map. Now let's learn another important isoline, that is Isohel. An isohel is a line that connects places receiving the same duration or intensity of sunshine over a specific period. For example, if different places receive the same number of sunshine hours in a day or a year, they can be connected by an isohel. Isohel are useful for studying the distribution of solar energy across different regions. They also help in long-term climatic studies and are very important for planning solar power projects, as they identify areas with higher sunshine potential. In simple words, an isohel is a line joining places with equal sunshine duration or intensity on a map. Now let's move on to the next type of isoline, that is Isoneph. An isoneph is a line that connects places having the same amount of cloud cover at a particular time or over a specific period. Here, cloud cover means the portion of the sky that is covered by cloud. Isoneph help meteorologists study the distribution of cloud, analyze daily weather conditions, and track the movement of atmospheric moisture. They are also useful for understanding weather changes and improving weather forecast. In simple words, an isoneph is a line joining places with equal cloud cover on a map. Now let's learn about another important isoline, that is Isotach. An isotach is a line that connects places having the same wind speed at a particular time. Here, wind speed is usually measured in knots or kilometer per hour. As you can see in the figure, places with a wind speed of 50 knots are connected by one isotach, while places with 100 knots are connected by another isotach. Isotach are very useful for identifying areas of strong winds. They help meteorologists forecast severe weather events such as storms and cyclones. Isotach are also important in aviation because pilots use wind speed information to plan safe and efficient flight routes. In simple words, an isotach is a line joining places with equal wind speed on a map. Next, we will learn about another important isoline, that is Isodrosotherm. An isodrosotherm is a line that connects places having the same dew point temperature. What is dew point? The dew point is the temperature at which water vapor in the air begins to condense into teeny water droplets. It is an important measure of atmospheric moisture. For example, places with a dew point temperature of 60 degrees are connected by an isodrosotherm, while places with 65° or 70° are connected by different isodrosotherms, as shown on the figure. Isodrosotherm helps us study the distribution of humidity. They are also useful for predicting weather conditions such as fog, frost, and even thunderstorm. In simple words, an isodrosotherm is a line joining places with equal dew point temperature on a map. So far, we have learned 7 important types of isolines. Now, let's understand why isolines are so important in climatology. First, isolines simplify complex weather data. Instead of looking at hundreds of numbers, they present the information as clear and easy to understand lines on a map. Second, isoline make it easy to compare climatic conditions between different regions. For example, we can quickly identify which areas are hotter, wetter, or have higher air pressure. Third, isoline play an important role in weather forecasting. They help meteorologists predict changes in temperature, rainfall, pressure, wind, and other weather conditions. Finally, isolines are very useful for planning. They support agriculture, water resource management, urban planning, disaster management, and environmental studies. In simple words, isolines transform complex climatic data into meaningful patterns, making them an essential tool in climatology. Before we end today's video, let's quickly revise all the important isolines we have learned. Isotherms connect places with equal temperature. Isohel connects places with equal sunshine duration. Isohyet connects places with equal rainfall. Isoneph connects places with equal cloud cover. Isodrosotherm connects places with equal dew point temperature. Isobar connects places with equal atmospheric pressure. Isotach connects places with equal wind speed. You can take a screenshot of this slide and use it for quick revision note. Thank you for watching this video. I hope this lesson helped you understand the different types of isoline. If you found this video helpful, please like, share and subscribe to Geography with Sumona. See you in the next video. Thank you.